Hello everyone. So today we will talk about in further details about the applications of stacks. Of the arithmetic expression, that is the very first application of stacks. So let's suppose if there is an arithmetic expression given which has certain values in a random manner. These values have been given. That means, say, let's take these symbols. So before moving to the actual example, I just want to share with you one information, that there are different operators and operands in an arithmetic expression that we all know. So when we apply the stacks to evaluate any particular arithmetic expression, we keep the one thing in mind: the priorities of the operators. That means if there are two operands A, then an operator B, then this will be an arithmetic expression. This will be a very simple or the simplest arithmetic expression possible, where the operator could be anything: plus, minus, multiplication, division, or a power to operator, which is also known as exponent. So all out of all these five, they are arranged in a particular hierarchy of priority. So the highest priority operator is the exponent. Then we have multiplication and division. They both, multiplication division, have the equal priority but are lower than the exponent. Similarly, addition and subtraction both have the same priority but are lower, having the lowest priority of all the existing operators. So now let's understand through an example how we can use a stack to evaluate any particular arithmetic expression. So taking this example, this is the arithmetic expression where the operators and operands are arranged accordingly, either by the prefix or the postfix manner. This will be discussed later, what is prefix and postfix. Just for the sake of understanding, understand that these are the symbols where some of them are operators and some are operands. So what I am doing is, to use that, I have created a table which has two columns: symbol and stack. So one by one I'll start scanning the symbols from left to right. The very first symbol that will be scanned will be 5. And whenever you are scanning, the rule is, whenever you are scanning a symbol which is an operand, the operand is simply added to the stack or is pushed to the stack. And whenever you encounter an operator, you have to pop two elements from the stack, A and B, and then you evaluate B operator A and put the result back onto the stack. So let's see how this happens. So 5 is an operand, put it to the stack. 6 is an operand, put it to the stack. 2 operand, put it to the stack. Then we have plus, which is an operator. So as we have encountered an operator, I will pop two elements, A equal to 2 and B equal to 6. And now I will calculate B operator 2. B operator A, which means 6, the operator is plus, so 6 plus 2, the result is 8. So now the result will be pushed to the stack. So 8 will be pushed back to the stack. Then the next symbol scanned is again an operator, which is multiplication. So B and A both will be popped out of the stack. So B will be 5 and A will be 8. So 5 into 8, 40. Next is 12, push to the stack. 4, push it to the stack. Then we have division. So what I will do, 12 divided by 4, 3, and then 3 will be pushed back to the stack. Then we have minus, which is an operator. So 40 minus 3 is 37. So this is the final result of this arithmetic expression will be 37. Then let's take another example. Here I am not giving you the expression, but you can see these are the order in which the symbols are being scanned. So 12 operand onto the stack, 7 onto the stack, 3 push to the stack. Minus is an operator, so 7 minus 3 is 4. 4 is pushed onto the stack. Then division. Division means 12 divided by 4. This is 3. Then you have 2. 2 will be pushed onto the stack, 1 pushed onto the stack, 5 pushed onto the stack. Then we have plus. So 1 plus 5 is 6. and then 6 is pushed onto the stack. Then multiplication, 2 into 6 is 12, and then we have plus, so 3 plus 12 is 15, push back to the stack. So 15 will be the final answer for this particular example. Now the next application is prefix and postfix conversion. Before moving on to that, let's assume an arithmetic expression like a plus b into c minus d. So this is a kind of arithmetic expression which is represented in the infix form. So what is infix form? When you have the operator lying between or within the operands, that is known as an infix expression. When the operator is placed before the operands, it is known as the prefix notation or the polish notation. When you have the operator placed after the operands, that is known as the postfix notation or the reverse polish notation. So if you have a very simple expression like this, you can simply convert it using manually by simply see what I can do is I can consider this bracket as x and this bracket, the second bracket, as y. So x into y. Now x can be resolved as plus ab and y can be resolved as division cd. And then x into y can be resolved as into x by 2. So replace x by plus ab and replace y by division cd. So this will give you the prefix notation. Similarly, you can evaluate for the postfix. But this is not the way you can evaluate for the huge expressions. So for that purpose, we have, or manually you can't do everything. So what we do, we have stack implementation for resolving this issue. For stacks, postfix, there are certain steps. So what I do for any infix operation, the first step will be push a left parenthesis onto the stack and add a right parenthesis to the end of the expression s. Now scan the symbols from left to right and repeat the steps 3 to 6 for each of the elements of this S until the stack is empty. If an operand is encountered, add it to the expression R. If a left parenthesis is encountered, push it to the operator is encountered, then add the operator onto the stack. If there is another operator on the top of the stack and the new operator has less or equal precedence, then pop the stack and add it to the expression. Push the new operator onto the top of the stack. Now, if a right parenthesis is encountered, then pop from the stack and add to the expression R and remove the left parenthesis, and then finally you have to exit. Now these are the rules. Now let's see how these rules can be applied to convert an fixed expression to the applications of stacks. the next application is prefix and postfix conversion. Before moving on to that, let's assume an arithmetic expression like a plus b into c minus d. So this is a kind of arithmetic expression which is represented in the infix form. So what is infix form? When you have the operator lying between or within the operands, that is known as an infix been done. So as you can see, what has been done is a plus, this is the expression, the inverse expression will be given by this, and then repeat the process of the previous algorithm of converting infix to the postfix. Once you have got the postfix expression, again reverse this, and it will give you the correct prefix expression.